What do a cactus in the desert, a polar bear in the Arctic, and you scrolling through YouTube right now all have in common? You might be surprised to hear it, but the answer is adaptation. It's a word we hear all the time, but what does it actually mean? Is it just about surviving, or is there more to the story? Today, we're diving deep into the fascinating world of adaptation. We'll unravel what it truly is, explore its different forms, and see how it's not just a story about ancient history, but something that's happening all around us, and even within us, every single day. So, let's get started. At its core, adaptation is the process by which a species becomes better suited to its environment. Think of it like this. The world is a giant, ever-changing puzzle, and every living thing is a piece of that puzzle. Adaptation is the process that slowly shapes each piece so it fits perfectly into its spot. This shaping doesn't happen overnight. It's a slow, gradual process that takes place over many, many generations. The engine driving this whole process is natural selection, a concept famously described by Charles Darwin. The idea is pretty straightforward. Within any population, whether it's squirrels in a park or bacteria in your gut, there's variation. Some squirrels are slightly faster, some have bushier tails. A certain trait, say a slightly thicker coat, gives a squirrel a better chance of surviving a cold winter and having more babies. That trait is more likely to be passed on to the next generation. Over time, that advantageous trait becomes more and more common in the population. That's adaptation in a nutshell. It's not about an individual animal deciding to change. It's about the entire species evolving over generations. Now let's break it down further. Adaptations generally fall into three main categories: structural, physiological, and behavioral. Hey, let's look at each one. First up, structural adaptations. These are the physical features of an organism that help it survive. They are the most obvious ones, the things you can see. Think of the sharp talons of an eagle, perfect for grabbing prey, or the long, flexible neck of a giraffe, designed to reach the highest, tastiest leaves that other animals can't get to. A fantastic example is the camouflage of a chameleon. Its skin can change color to blend in with its surroundings, making it nearly invisible to both predators and prey. That's a structural adaptation. Even plants have them. The waxy coating on a cactus's skin is a structural adaptation that helps it reduce water loss in the scorching desert sun. It's all about having the right physical tools for the job. Next, we have physiological adaptations. These are a bit trickier because you can't always see them. They're internal processes or functions that help an organism survive. Think of it as the body's internal software. A classic example is venom production in snakes. The snake's body has a special biochemical process to create a complex cocktail of toxins. This isn't a physical feature you can see from the outside, but it's a powerful tool for hunting and defense. Another great example is hibernation. When a bear hibernates, its body goes through massive internal changes. Its heart rate slows down, its body temperature drops, and its metabolism grinds to a near halt. This is a physiological adaptation that allows it to conserve energy and survive the long, cold winter when food is scarce. Even we humans have them. When we go to a high-altitude area, our bodies start producing more red blood cells to carry oxygen more efficiently. That's our body's physiological adaptation to a low-oxygen environment. Finally, we have the third category, behavioral adaptations. These are the things organisms do, their actions, that help them survive. It's about behavior, not body parts or internal chemistry. A perfect example is migration. Every year, millions of birds like the Arctic tern fly thousands of miles from the Arctic to the Antarctic and back again. This incredible journey is a behavioral adaptation. They do it to follow the food and find the best conditions for breeding. They are unborn with wings that are specifically for long-distance flight, in a way that other birds are but they are born with the instinct to make this journey. Another example is how meerkats work together, live in groups, and have designated sentinels that stand guard, watching for predators while the others forage for food. If the sentinel spots danger, it gives a specific alarm call, and everyone scurries to safety. This cooperative behavior is a learned and instinctual adaptation that dramatically increases their chances of survival. So we have the what structural, physiological, and behavioral changes. But it's crucial to remember that these aren't mutually exclusive. Often, they work together in a beautiful, integrated way. Let's go back to our polar bear. It has structural adaptations, like its thick white fur for camouflage and insulation, and a thick layer of blubber. It has physiological adaptations, like its specialized metabolism that can handle a high-fat diet of seals. And it has behavioral adaptations, like its hunting techniques for stalking seals on the ice. All three types of adaptation work in concert to make the polar bear the ultimate Arctic survivor. One common misconception is that adaptation is a conscious process. An animal doesn't think, gee, it's getting cold, I'd better evolve a thicker coat. It doesn't work that way. It's all about random genetic mutations. Most mutations are neutral or even harmful. But every once in a while, a random mutation happens to give an individual a slight advantage. That individual is more likely to survive and reproduce, passing that lucky gene on. Over eons, these small, advantageous changes add up, leading to the incredible diversity of life we see today. It's a passive process of filtering, not an active process of striving. And this process never stops. Environments are constantly changing. A volcano erupts, an ice age begins, a new predator arrives, or a virus emerges. As the environment changes, the rules of the game change, and the pressure to adapt starts all over again. What was once a perfect adaptation might become useless, or even a disadvantage. For example, the large size of the dinosaurs was a great advantage for a long time. But when the environment changed drastically after the asteroid impact, that large size, which required huge amounts of food, became a major liability. Today, the biggest driver of environmental change is us, humans. Our activities are changing the planet at an unprecedented rate, and we are seeing evolution and adaptation happen in real time. We see it in bacteria that develop resistance to our antibiotics. This is a classic example of rapid adaptation. The few bacteria that happen to have a random mutation making them resistant to a drug survive the treatment and then multiply, creating a whole population of resistant superbugs. We also see it in urban wildlife. City pigeons and rats are masters of adaptation, thriving in environments that are completely man-made. They've adapted their behavior to eat our trash and navigate our concrete jungles. So, to wrap it all up, what is adaptation? It's not just about survival of the fittest. It's the multifaceted, ongoing story of life's incredible ability to find solutions. It's the physical tools, the internal chemistry, and the clever behaviors that allow a species to thrive in its specific corner of the world. It's a process driven by random chance and filtered by the relentless pressures of the environment, playing out over millions of years. From the smallest bacterium to the largest whale, every living thing is a testament to the power of adaptation. It's the beautiful, complex dance between life and its ever-changing home. So next time you see a bird building a nest, a squirrel burying a nut, or even when you shiver in the cold and your body starts to warm itself up, remember you're witnessing adaptation in action. It's the fundamental process that connects us all and makes life on Earth so resilient and so spectacular. Thanks for joining me on this deep dive into adaptation. If you found this interesting, don't forget to hit that like button and subscribe for more explorations into the amazing world of science. Let me know in the comments what your favorite example of adaptation is. Till next time, stay curious.